Now my dear friends, we move on to the second part. The first part is done. Second part of 3 molecules, and that will be with respect to oxygen, fluorine and neon. Now you will ask me, sir, what about boron, carbon and nitrogen? I'll explain you that also, chill. But as I told you, my priority is to make you understand the concept very easily. So I change my style of teaching so that you understand it. So that's the reason. First I will explain you oxygen, fluorine and neon. Alright? And on the basis of that, boron, carbon and nitrogen will become very easy for you to understand. Alright? So, in this part, we have 3 molecules, oxygen, fluorine and neon. But my statement still remains the same. If you understand oxygen, then with minor changes, we are going to get fluorine as well as neon. Alright? So we begin with. We start with the oxygen molecule. The formula of which will be O2. Okay? Now, we start, remember those 7 points? Yes. We start with the first point, and that is electronic configuration of the combining atoms. And that is, here it is oxygen, atomic number is 8. So we go into its electronic valence configuration. So it is 2s2 and 2p4. So that means total number of electrons per oxygen are 6. So for 2 oxygen there will be 12 electrons. Okay, so that is point number 1. Electronic configuration of combining atoms. Point number 2, yes, you know it very well. Overlapping of atomic orbitals. So here we begin with, we have a 2p orbital also over here, so we need to keep all these things in mind. So when we talk about the 2s orbital first of all, so the 2s orbital of both oxygen atoms overlap, resulting in the formation of 2 molecular orbitals, because 2s orbital of one oxygen, 2s orbital of another oxygen. So in this way, the 2s orbitals of both the oxygen atom overlaps, resulting in the formation of 2 molecular orbitals. And you know what they are? Yes, it's sigma, because it is 2s. So it is sigma 2s and sigma star 2s. Okay, this is one part. Now we talk about 2p. Now let me be very clear about 2p orbitals. 2p orbitals are of 3 types, 2px, 2py and 2pz. Z एक्सिस को बॉन्डिंग एक्सिस कंसीडर करते हैं हम लोग, और जब बॉन्डिंग एक्सिस के along the bonding axis अगर overlapping होता है, then it is sigma. And sigma bonds are stronger than pi bonds, and therefore sigma molecular orbital have a lower energy as compared to pi bonding molecular orbitals. Okay, it's as simple as that. So what we are going to consider is 2pz orbitals of both oxygen atoms overlap. It will also result in 2 molecular orbitals, which are those sigma 2pz and sigma star 2pz. Okay? Because it is Z is the bonding axis. इसलिए therefore overlapping will take place axially along the axis, and therefore it is resulting in sigma. Apart from 2pz, there will be 2px and 2py. They are perpendicular to the bonding axis, and you know very well, if it is perpendicular to the bonding axis, then it will result in what? Yes, pi bonding. So 2px and 2py, both of them are going to result in what? Pi bonding. Okay, this I have already explained you in my previous video of molecular orbital theory, when I was discussing about the differences between the sigma and the pi molecular orbitals. So what you have to say is 2px and 2py orbitals of both oxygen atoms overlap, and that will result in 4 molecular orbitals. कैसे 4 आया? 2px and 2py, ये दो ऑर्बिटल है एक ऑक्सीजन का, तो दो ऑक्सीजन का कितना हो जाएगा? 4. ओके, और वो कैसे लिखेंगे हम लोग? pi to px, pi to py, pi star to px and pi star to py. Okay, this way. Pi to px, pi to py, pi star to px and pi star to py. So this is about overlapping of atomic orbitals. ठीक है? Next, we go into distribution of electrons in the molecular orbital. तो ये आपको इजी करने के लिए मैं क्या करता हूँ, यहाँ पर साइड में आपको लेवल्स बता देता हूँ, एनर्जी लेवल्स, तो आपको इजी हो जाएगा. वी हैव सिग्मा 2s, उसके बाद है सिग्मा स्टार 2s, उसके बाद है सिग्मा 2pz, उसके बाद है पाई 2px and pi 2py. Okay, because both of them are 2p orbitals, both of them are forming pi, so that means the energy level are same, so they are called as degenerate. Okay, ये हो गया bonding किसका? 2p का. अभी एंटी बॉन्डिंग ऑफ 2p के लिए what we do is we consider a mirror image. तो जब pi 2px and pi 2py and I am going to consider that there is a mirror over here, तो उसका mirror image क्या आएगा? ऐसे आएगा. तो pi star 2px and pi star 2py, और यहाँ पर आएगा सबसे ऊपर सिग्मा स्टार 2pz. तो ये मैं आपको लेवल्स बता देता हूँ, so that ये रफ में बता रहा हूँ, बाद में of course I will be explaining you the fair molecular orbital diagram. So with these levels in your mind and with the rules in your mind, that from lower energy we have to go to higher energy. Electron will not go to the higher energy level till the previous lower energy level is completely filled. Okay, so ये सब rules ध्यान में रखेंगे तो you will get an idea about where the electrons are going to be arranged. So you need to know for the electronic configuration how many number of electrons to be arranged and what are the order of energy. Okay, ये दो चीजें आपको मालूम होनी चाहिए. So how many electrons we have to arrange? 6 per oxygen. तो दो ऑक्सीजन का कितना होता है? 12. So 12 electrons I need to arrange. So कैसे करेंगे हम लोग? पहले जाएगा सिग्मा 2s में 2 इलेक्ट्रॉन. Okay, then it will go in sigma star 2s, so that is 4 electrons. Then it will go in sigma 2s, 2 electrons. तो total कितना हो गया? 6. अभी 7th electron will go in pi to px and 8th electron will go in pi to py. अब ये बोलोगे कैसे? Yes, it's Hund's rule. Hund's rule what it says? Till the available orbitals, मतलब containing same energy, does not contain singly paired electrons, pairing doesn't take place. तो जब तक सारे ऑर्बिटल्स जो अवेलेबल का मतलब क्या है? जिसका एनर्जी लेवल सेम है. तो जब तक सारे सेम एनर्जी लेवल ऑर्बिटल्स के पास एक इलेक्ट्रॉन नहीं है तब तक पेयरिंग नहीं होगा. ओके, इसलिए 7वां इलेक्ट्रॉन pi to px, 8वां इलेक्ट्रॉन pi to py. Now what about the 9th electron? Is it going to go into pi star? No, it's not. Because what is the rule? Till the previous one is not completely filled, the electrons cannot go into that. So 9th electron pi to px, 10th electron pi to py, 11th electron will go in pi star to px, and 12th electron, Hund's rule, yes, pi star to py. समझ में? So this is the way the arrangement is. So once again I repeat, first 2 electrons is sigma 2s, 3rd and the 4th electron sigma star 2s, 5th and the 6th electron in sigma 2pz, 7th in pi to px, 8th in pi to py, 9th in 2px, 10th in pi to py, 11th in pi star to px and 12th in pi star to py. Understood this? So this is what is the distribution of electrons. So we'll start writing down now. That is 2 electrons occupy each of, अभी कौन से sigma 2s, sigma star 2s, sigma 2pz, pi to px and pi to py. 2 electrons occupy each of these orbitals and 1 electron in pi star to px and pi star to py. तो देखो काउंट करो अभी 1, 2, 3, 4 and 5. these 5 orbitals contains 2, 5 2 सा कितना होता है, where 10, और इसमें 1 इलेक्ट्रॉन है, 1 electron in pi star to px and 1 electron in this, मतलब 2 इलेक्ट्रॉन. So 10 plus 2 is 12. ये देखो आप 6 पर ऑक्सीजन, तो 2 ऑक्सीजन का कितना, 12 इलेक्ट्रॉन. तो इस तरीके से अरेंजमेंट हो चुका है. So this is about distribution of electrons in molecular orbit. We move to the next category, and that is what? Yes, electronic configuration of the molecule. बहुत सिंपल है दोस्तों, इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ द मॉलिक्यूल के लिए you are going to write down all those molecular orbitals from lower energy to higher energy which contains electrons. नीचे से ऊपर तक सारे molecular orbital लिख दीजिए जिसमें इलेक्ट्रॉन्स है. तो शुरू करते हैं. sigma 2s2, sigma star 2s2, sigma to pz2, pi to px2, pi to py2, pi star to px1 and pi star to py1. वापस से काउंट कर लेते हैं एक बार इलेक्ट्रॉन्स. 2 और 2 4, 6, 8, 10, 11, 12. So in this way there are going to be 12 electrons, okay, which are going to be arranged in this particular molecule. ठीक है? So this is point number 4, electronic configuration of the molecule. Point number 5, और वो क्या है? Yes, it's the bond order. फॉर्मूला तो आप जानते ही हो अच्छी तरीके से. It is half into number of electrons of bonding minus number of electrons in anti-bonding. So how many electrons are there in bonding? Without star, please count the electrons. So 2 electrons, or you can see over here also 2, 4, 6, 8. So 8 electrons without star. Now with star, 2, 3, 4. The answer is 2. Okay, and therefore we say there exists a double bond between the 2 oxygen atoms. Okay, so that is bond order. The last part we go into, and that is magnetic property. Now if you can have a clear look at it, at the arrangement of electrons, तो आप देख सकते हो pi star to px and pi star to py. Okay, इसमें आपको एक एक सिंगल इलेक्ट्रॉन दिखाई देगा pi star to px और pi star to py में. So there are 2 single electrons. और इसलिए you understood? Yes, it is paramagnetic. Okay, whenever there are going to be single electrons, it is going to be what? Paramagnetic. If all the electrons are paired, ये word मैंने stress किया था, अगर आपको याद है, all, तो ही वो डायमैग्नेटिक हो. ओके, ये सारे पेयर्ड है, लेकिन यहाँ पर क्या है, ये दोनों सिंगल है. सो दैट्स व्हाई वी से इट इज व्हाट? पैरामैग्नेटिक. सो दिस इज माय डियर फ्रेंड्स अबाउट oxygen molecule, the 6 points. The points are same, only thing is there is an addition because of the 2p orbitals. Okay, so please have a look at it and see whether you have understood all the 6 points with respect to oxygen. Okay, and that is when we consider the 2s orbitals as well as the 2p orbitals both. Okay, have a look at it and just check out. I'm very sure you must have understood this. और फिर इसमें जैसे पहले भी मैंने बताया था, माइनर चेंजेस करके बताऊंगा कि एक बार ऑक्सीजन समझ में आ गया तो फ्लोरीन और नियॉन बहुत इजी है. Okay, so I guess it's being clear. So after oxygen molecule, we go to the next molecule. Okay, and that next molecule obviously is going to be a fluorine molecule. So this will be F2. Changes over here, fluorine, atomic number is 9. So this will become 2s2 and 2p5. So 7 electrons per fluorine. So total in a fluorine molecule will be 14. When we talk about overlapping of atomic orbitals, changes कहाँ पर आएगा? जहाँ पर भी मैंने O लिखा है ना, वहाँ पर F आएगा. Okay? Otherwise, no other changes. Okay? The O is replaced by what? F, and that is going to give you all this. Distribution of the electrons in the molecular orbital. अब इसमें देखो, I have shown the arrangement up to 12 electrons. Here how many we have to arrange? 14. So that is 2 more electrons. So where the 13th electron is going to go? It's not going to go in sigma star to pz9. क्योंकि ये खाली है. So 13th electron is going to go in pi star to px, and the 14th electron will go in pi star to py. Okay, तो 2 इलेक्ट्रॉन जो ऐड हुआ है, तो 1 इलेक्ट्रॉन will go in pi star to px, other will go in pi star to py. तो अभी हमें क्या करना है? डिस्ट्रीब्यूशन ऑफ इलेक्ट्रॉन्स. 2 electrons occupy each of, अब ये जो मैंने लिखा है ना and 1 electron, वो हटा दें. ओके, तो ये भी इसके साथ जुड़ जाएगा अभी. तो 1 2 3 4 5 6 7 orbitals, each of which containing 2 electrons. So 7 into 2 is 14, and this is what I have to arrange, 14 electrons. Okay, so ये हो गया. इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऑफ द मॉलिक्यूल में क्या चेंजेस करना है? pi star to px 1 था, तो वो pi star to px 2, pi star to py 1, so you make it as pi star to py 2. That's it. Next, what is another change? Bond order. I have added 2 electrons in anti-bonding. Okay, the 2 electrons which are added is going into what? Anti-bonding. So where it was 4, now it becomes 6. So now this will become 1. So now instead of a double bond, I'll be writing what? A single bond between the 2 fluorine atoms. Okay, there is going to be a single bond between the 2 fluorine atoms, and you can see this arrangement. So everywhere you can see the electrons are paired, and therefore I need to replace this statement by which statement? That all electrons are paired, and therefore it is diamagnetic. Okay, so once again, as usual, I told you, with some minor changes you got the next molecule, and that is fluorine molecule. Okay, minor changes किया, आप देख सकते हो. Okay, live demonstrate करके दिखा रहा हूँ मैं आपको. Okay, कि हर एक पार्ट का पहला molecule, if you understand, the other molecules becomes much more easier. So please have a look at fluorine molecule, everyone. Okay, we go to the next molecule, the last molecule of this particular part, and yes, that is what? The neon molecule. So the changes in the symbol is Ne2, neon, atomic number will be 10. This will become 2s2 and 2p6. So that means 8 electrons in the valence shell. And when you talk about the overlapping of atomic orbitals, it all remains the same. Only thing is, instead of F, it will be now replaced by what? Neon, that is Ne. Everywhere it will be replaced as Ne. Okay. Distribution of the electrons in the molecular orbital, what we are going to do, ये देख रहे हैं आपको sigma star to p से वो ऐड कर देना है आपको. ओके, और कुछ करना नहीं है. यहाँ पे 2 इलेक्ट्रॉन्स ऐड कर देंगे. तो what we have is pi star to p x, pi star to p y, and then we are going to add sigma star to p z. तो इधर भी 2 इलेक्ट्रॉन्स ऐड हो जाएगा. So electronic configuration of the molecule, we have sigma star to p z 2. तो इस तरीके से you can count 1 2 3 4 5 6 7 8 into 2 is 16 electrons मुझे arrange करना है. I have to add 2 more electrons to the antibonding. So 8 minus of 8, it comes out to be what? 0. And therefore, yes, समझा ना आप लोगों को? Very good. Okay, and that is what you are going to say is Ne2 molecule does not exist. Okay, Ne2 molecule does not exist because it is 0. So He2 molecule does not exist, Be2 molecule does not exist, and Ne2 molecule does not exist. So that means it is monoatomic. And when you consider the last line, ज़्यादा मायने नहीं रखता है क्योंकि when molecule only doesn't exist, so obviously whether it is diamagnetic, paramagnetic, not of much use. तो ये था दोस्तों about neon. Okay, so please have a look at it. Yes. So now I guess you are all very much confirmed with my statement that if you understand the first molecule of that particular category, you will understand the remaining categories. मैंने ऑक्सीजन मॉलिक्यूल आपको पढ़ाया था और उसी ऑक्सीजन मॉलिक्यूल में माइनर चेंजेस किया, I explained you fluorine, और उसी में माइनर चेंजेस किया, I explained you neon. So I hope you are getting this very well. Now I will be showing you what? Yes, the most important, the seventh point, and that is the molecular orbital diagram of these three molecules. So after going through all the 6 points, we now go into the last point, and that is the molecular orbital diagram. So I will be drawing the molecular orbital diagram in front of you. So you understand this very well. This is with respect to energy. Okay. Now on one side, I'm going to start with oxygen molecule first of all. So atomic orbital of oxygen, atomic orbital of oxygen, and center we have molecular orbital of O2. Okay. Next, as usual, when you talk about 1s, I'm just going to write down as non-bonding. At the same energy level it will be. So please remember that it is same energy. I don't have a scale, but then you need to please keep this in mind very well. It is same energy. Okay, because the elements are same. So it is 1s. Now we are going to start with the 2s orbitals. Two A's of one oxygen, two A's of another oxygen, and now they are going to overlap, resulting in the formation of bonding as well as anti-bonding. So we have sigma 2s, and this we have as sigma star 2s. Okay. Now we go into the next one, and that is the 2p orbitals. 2p orbitals are of three types: 2px, 2py, and 2pz. Similarly here also, on the same straight line, we are going to show the 2p orbitals of another oxygen. Now we have two levels for bonding, two levels for anti-bonding. Why? Yes, you know that. क्योंकि एक सिग्मा बनाएगा और एक पाई बनाएगा, और सिग्मा और पाई दोनों का एनर्जी लेवल तो अलग अलग होगा. So two levels you are going to show for bonding, and two levels you are going to show for anti-bonding. This way. Okay. So जो lower level है sigma, so it will be sigma to pz. ये जो degenerate orbitals, so degenerate means having same energy, will be pi to px and pi to py. Then if you remember, मैंने बोला था आपको consider a mirror over here, so उसका mirror image will come over here. So it will be pi star to px and pi star to py, and right at the top we have sigma star to pz. Alright, this is the way the arrangement is. So this is the basic structure, okay, of the molecular orbital diagram. Okay, और वो same होगा for oxygen, fluorine as well as neon. Only thing is the arrangement of electrons will change. So first of all we are going to start with oxygen. So oxygen में 1s2. Okay, first of all always fill up the atomic orbitals and then go for the filling up of molecular orbitals. 2s2 to p4. How to show the to p4? Hans rule. Yes. 1, 2, 3, and then the fourth electron will pair up. Similarly here also. Alright, done. Next is, the rule is very simple. Left plus right is equal to center. So 2 plus 2 has to be 4 over here. So it's very simple. 2 electrons down, 2 electrons up. Finished. No tension. Abhi aate p orbitals. 4 plus 4. 8 electrons I have to arrange. So how should I arrange those 8 electrons in these? Rules are very clear. So what we do is 2 electrons, okay, यहाँ पर आएगा, total 8 है, तो 2 इधर आ गया, third in pi to px, fourth in pi to py, okay, fifth in pi to px, sixth in pi to py, Hans rule follow करना है, seventh electron will go in pi star to px, and the eighth electron according to Hans rule, pi star to py. तो ये देखो ये 4 ये 4 कितना हुआ 8 काउंट करो यहाँ पे 2 4 6 7 8 so left plus right is equal to center. So this is, my dear friends, the molecular orbital diagram for oxygen molecule. So I hope you have understood this. Two single electrons in the pi star orbital makes it what? Paramagnetic. So oxygen molecule is paramagnetic according to this molecular orbital theory. So please have a look at it, everyone. Alright, now on the basis of this oxygen molecule, we will now go into fluorine molecule. It will get over in within seconds. देखो कैसे होता है. पहले तो O को replace करो by F. टू एस टू पी 5 है, तो यहाँ पर एक इलेक्ट्रॉन ऐड करना पड़ेगा. We have to add one electron over here, so that means 2 electrons we have added. So one electron will go in pi star to px and the another electron will go in pi star to py. The added electron I am talking about. Okay, तो वो इस तरीके से जाएगा. And देखा आपने, few seconds लगता है. एक बार ऑक्सीजन मॉलिक्यूल का डायग्राम्स क्लियर है, फ्लोरीन बहुत इजी हो जाता है फिर. Okay, so this is what is the molecular orbital diagram of fluorine. You can see all the electrons are paired. Center पे देखो दोस्तों, because center is molecular orbital, so all the electrons are paired, and therefore we say the molecule is dimagnetic. Okay. So once fluorine is clear, we go into the next one. Once again, just few seconds, and we get a neon molecule. So F is replaced by any neon. This will be Ne2, and this will be Ne. Alright? So 2s2 hai, so one electron to be added over here, one electron to be added over here. So 2 electrons are added. So those added 2 electrons, where it will go? Sigma star to pz. Okay? अब आप देख सकते हो, the number of electrons in bonding is equal to the number of electrons in anti-bonding. Whether it is 2s में तो पहले से था, अभी 2p में भी ऐसा हो गया, that total there are 6 electrons in the bonding, there are total 6 electrons in anti-bonding, they both cancel each other, bond order comes out to be what? 0, और इसलिए मैंने आपको बोला था, neon molecule does not exist. Okay, so please have a look at this diagram, molecular orbital diagram of neon molecule.